Please subscribe and tap the bell icon.
Exercise 1b, first bit, first question. F of x equals to e power x and g of x equals to log x. Log x to the base e. We need to show that fog equals to gof and find f inverse and g inverse. So first, if I take fog of x, that equals to f of g of x, which is equals to g of x equals to f of log x to the base e, that equals to f of x nothing but e power log x to the base e. We know that e power log x to the base e equals to x, and similarly if I take gof of x, this will be equals to g of f of x, that equals to g of e power x, that equals to log of e power x to the base e, that equals to, so this is log e power x to the base e, that equals to x into log e to the base e. Log e to the base e equals to 1, that equals to x. Whenever they give fog or gof, we need to consider g of x, f of g of x or g of f of x, whatever the variable we have here, that we need to consider. To find the f inverse, let y equals to f of x. That implies x equals to f inverse of y. If I take y equals to f of x equals to e power x, that implies if I bring this e to the left hand side, then I'll get log y to the base e equals to x. X equals to f inverse of y equals to log y to the base e. This f inverse is in the variable y. If I write this in terms of f inverse of x variable, this is log x to the base e. I'm just changing this variable here, that's it. So this is my f inverse of x. Similarly, to find g inverse, let y equals to g of x. That implies x equals to g inverse of y. So this is separate question till here, and now it's separate. We need to do it separate. Y equals to g of x is nothing but log x, the base e. That implies x equals to e power y. If I bring this log e to the left hand side, it becomes e power y. F inverse of y equals to e power y. F inverse of x equals to e power x. So this is g inverse of x. I took g inverse of x. So g inverse of x equals to e power x. Second bit, if f of y equals to given as y by root 1 minus y square and g of y equals to y by 1 plus y square, show that fog of y equals to y. We need to do this. Fog of y is nothing but f of g of y, that equals to f of g of y equals to y by root 1 plus y square, that equals to, so this is f of x. F of y by 1 plus root 1 plus y square becomes y by root 1 plus y square In the place of this y, I need to substitute this entire value here, divided by root 1 minus y square is nothing but y by root 1 plus x square, y square whole square, that equals to y by root 1 plus y square by square root of 1 minus, this is y square by 1 plus y square, that equals to y by root 1 plus y square whole divided by, taking the LCM here, 1 plus y square minus y square by 1 plus y square. These two gets cancelled, and this total thing is 1 by root 1 plus y square. These two gets cancelled, that equals to y. Next, third bit, f is mapping from R to R and g is mapping from R to R, and f of x is defined as 2x square plus 3 and g of x is defined as 3x minus 2. We need to find first one, fog of x. This is equals to f of g of x, that equals to f of g of x is given as 3x minus 2. Now f of 3x minus 2 becomes 2 into 3x minus 2 whole square plus 3, that equals to 2 into, this is a minus b whole square, expand that, this is 9x square plus 4 minus 2ab. So 2 into 3x into 2 is 12x plus, that equals to 18x square plus 8 plus 3 is 11, and 2 into minus 2x is minus 24x. So this is the expression we get here. Second one, we need to find gof of x, that equals to g of f of x, that equals to g of f of x is given as 2x square plus 3, that equals to, g of 2x plus 3 becomes 3 into 2x square plus 3 minus 2, that equals to 6x square plus 9 minus 2, that equals to 6x square plus 7. This is gof of x. And third one, f of 0, that equals to f of 0 equals to f of 0 will be, if I substitute 0 in the place of x, f of 0 will be 3, and f of 3 will be equals to 2 into 3 square plus 3, that equals to 2 into 9 plus 3, that equals to 21. Fourth bit is so this is a given question. This is equals to g of f of 3. So we get two functions inside g function, that equals to g of f of 3. So the value of f of 3 is, in the place of x, if I substitute 3, this is 2 into 9 plus 3 is 21. So f of 21, that equals to g of, again f of 21 we need to find. F of 21 is 2 into 21 square plus 3, that equals to g of 21 square is 441, 21 square is 441. 441 into 2. 21 into 21 is, so this is 441. 441 into 2 is 882. This equals to G of 885. G of 885 equals to 2 into 885 minus 2. So 885 into 2 we need to find here. 885 into 2 is, so this is 3 into 885 minus 2. So 2655 minus 2, that equals to 2653. This is the value. Next is fourth bit. F is mapping from R to R and also G is mapping from R to R. F of x is defined as 3x minus 1 and G of x is defined as x square plus 1. We need to find f of x square plus 1, that equals to f of x square plus 1. This is equals to f of, now f of x square plus 1 will be 3 into, in the place of this x substitute x square plus 1 minus 1, that equals to f of 3x square plus 2. Again f of 3x square plus 2 will be 3 into 3x square plus 2 minus 1, that equals to 9x square plus 9 minus 1 is plus 8. And second bit, fog of 2, this is equals to f of g of 2, that equals to f of g of 2 equals to 2 square plus 1, that equals to f of 5, and f of 5 will be equals to 15 minus 1 is 14. Third bit is cof of 2a minus 3, that equals to g of f of 2a minus 3, that equals to g of f of 2a minus 3 will be 3 into 2a minus 3 minus 1, that equals to g of 6a minus 10. G of 6a minus 10 will be 6a minus 10 whole square plus 1, that equals to, this is a minus b whole square expansion, this is 36a square minus 120a plus 100 plus 1 is plus 101. This is the value of cof of 2a minus 3. Next, fifth question. If f of x equals to 1 by x and g of x equals to root x for all x belongs to 0 to infinity, find cof of x. Cof of x will be equals to g of f of x, that equals to g of f of x will be equals to 1 by x and g of 1 by x equals to square root of 1 by x, that equals to 1 by root x. Sixth question, if f of x equals to 2x minus 1, g of x equals to x plus 1 by 2, find cof of x. So g of f of x is nothing but 2x minus 1 and g of 2x minus 1 is 2x minus 1 plus 1 by 2, that equals to 2, so that equals to x. Seventh question, if f of x equals to 2 and g of x equals to x square and h of x equals to 2x for x belongs to R, find gof of x. Find, so this is f of goh of x. This we need to find. This will be equals to f of g of h of x, that equals to f of g of h of x equals to 2x, that equals to f of g of 2x will be 2x whole square, that equals to f of 4x square, and f of 4x square equals to f of x is a constant function, that equals to 2. Eighth question, find the inverse of the following functions. First one, f of x equals to ax plus b, and f is mapping from R to R. We need to find the f inverse. Let y equals to f of x, that implies x equals to f inverse of y. So x will be equals to ax plus b, so y will be equals to ax plus b, and from this I can write that x equals to y minus b by a, that equals to f inverse of y. So f inverse of x will be equals to x minus b by a. Second question is, f is mapping from R to 0 to infinity, and my f of x is defined as 5 power x. We need to find the inverse of this. If y equals to f of x, that implies x equals to f inverse of y. So y equals to 5 power x, that implies x will be equals to log y to the base 5. Or you can write it as log y by log 5. So both are correct here. F inverse of y will be equals to log y to the base 5. F inverse of x will be equals to log x to the base 5. This is my inverse function. Next, ninth bit. F of x is given as 1 plus x square plus x cube plus so on to infinity. We need to show that f inverse of x equals to x minus 1 by x. So 1 plus x square and so on up to infinity. This is a sum of n terms, and this is in GP. Sum of infinite series in GP. So the sum will be equals to a by 1 minus r, that equals to first term is 1 and the common ratio is x. This is 1 by 1 minus x. If y equals to f of x, x will be equals to f inverse of y. Y equals to 1 by 1 minus x, that implies y minus yx equals to 1, and y equals to 1 plus yx, y minus 1 equals to yx, that implies x equals to y minus 1 by y. X equals to, that equals to f inverse of y equals to y minus 1 by y. So f inverse of x will be equals to x minus 1 by x. Tenth question. F is mapping from 1 comma infinity to 1 comma infinity, and f of x is defined as 2 power x into x minus 1. We need to find the f inverse of x. Let y equals to f of x, that implies x equals to f inverse of y. X will be equals to f inverse of y. So from this I can write that y equals to f of x equals to 2 power x into x minus 1 log y to the base 2 will be equals to x into x minus 1. On sending this 2 to the left hand side, I'll get this log y to the base 2 equals to x into x minus 1. That equals to x square minus x. I can write that x square minus x minus log y to the base 2 equals to 0. We need to find the x value in this. Applying the quadratic formula, I'll get that x equals to minus b plus or minus root b square minus 4ac by 2a. That equals to minus b is 1 here, plus or minus root b square is 1 minus 4 into a is 1 and c is minus log y to the base 2. So 1 plus 4 log y to the base 2 by 2 into 1. I got the value of x as 1 plus or minus root 1 plus 4 log y to the base 2 by 2. But here, given that f is mapping from 1 to infinity to 1 to infinity, if my x is, let's say if my x equals to 1 minus root 1 plus 4 log y to the base 2 by 2, here I may get values ranging from 1 by 2 or else 1 by 2 or 0 to the negative values. But this is not in the range here. The range is from 1 to infinity. My 0, 1 by 2 and negative values are not supposed to be here. So x can take the only values as 1 plus root 1 plus 4 log y to the base 2 by 2. That equals to f inverse of y. I can write f inverse of x will be equals to 1 plus root 1 plus 4 log x to the base 2 by 2. This is the f inverse of x.